This is the solution to chapter 15 video assignment 2. The question asks, one common strategy employed is when it is important to get a mostly insoluble salt dissolved is to add a Lewis base to the solution. Explain why this works to help increase the amount of salt that dissolves. So I came up with a little example, but before we go through that, we'll define just what a salt is. It's composed of a cation and an anion, or multiple cations and anions that form an ionic compound. And they are formed frequently through an acid-base reaction. For example, sodium chloride, table salt, you can form by combining sodium chloride, NaOH, a base, and HCl, an acid, to form NaCl, which precipitates out, which is a salt. So that's what a salt is, an ionic compound, cation and anion, frequently a metal cation and a non-metal anion. And a Lewis base is a species that donates an electron pair. So for example, if you look like Bronsted-Lowry, acid-base stuff, hydroxide, OH-, donates its electron pair in an acid-base reaction. So that's what a Lewis base is. It's a species that donates an electron pair for a covalent bond to form. So why it is that adding a Lewis base to an insoluble salt causes it to dissolve is because the Lewis base essentially breaks off the cations and to form these complex ion complexes. And so an example is with the salt from the previous question, silver chloride. Here is the silver chloride solubility product, right, which we kind of talked about last time. The concentration of silver times concentration of chloride is equal to this value here. And the reaction is silver plus chloride equals silver chloride, right? And this is an insoluble salt. So to make this soluble in water, we can add a Lewis base, and a good example is cyanide, which is just a carbon atom and a nitrogen atom with this triple covalent bond and these two lone electron pairs. It has a negative charge. And so in these complexing reactions, the Lewis base that you add is called a ligand, and the cation is just going to be this metal ion that the ligand binds to. So with cyanide here, obviously with this reaction, there's always going to be some free silver ions in the solution, right? Nothing is 100% insoluble, right? That's impossible. So there's always going to be free silver ions. And when you introduce the cyanide, it's going to form this complex with silver. The two negatively charged cyanide ions are going to bind with the positively charged silver ion to make this little complex here. I do the Lewis dot structure. So here's your silver, and then here's your two cyanides that donate their electron pair to form this covalent bond on both sides. And this is going to have an overall negative charge, right? Because each of your cyanides has a -1 charge and your silver has a +1 charge. So overall will be a negative charge with this complex ion. Now the formation, similar to solubility products, you can determine the formation product, at equilibrium, the formation product. And for the silver cyanide complex ion, it's actually 1 × 10⁻²1, right? So the concentration of the silver cyanide complex ion here, divided by the concentration of silver and cyanide, is this huge number, 1 × 10⁻²1. So any of the free living silver ions in the solution are going to be complexed by cyanide to form this. Because this is so high, all of them are going to be used up, right? And according to Le Chatelier's principle, if the concentration of silver is going down, it's going to push this to the left. So all of your insoluble salt here is going to be breaking apart into its constituent pieces because this is just going to keep going down, your concentration of silver, right? The cyanide is going to keep binding to it to make this complex ion. Le Chatelier's principle means this is just going to keep going left. So if you add a sufficient amount of cyanide, eventually all of your solid sodium chloride is going to be dissolved. The silver in this complex ion, and your chloride obviously just as free living species in the solution. And so essentially that's how it works to dissolve an insoluble salt by adding a Lewis base. The Lewis base complexes with one of the constituent pieces of the salt to break it off, and because the dissociated ions in very small number within that solution are going to be complexed by the Lewis base. And so according to the Chatelier principle, all of the solid insoluble salt is going to dissociate as the Lewis base complexes with one of the ions.